Namaste. Welcome to Verilog session. I'm your Rohit DH from DWare Black Tech. Now, we are going to implement the half adder in XILINX Spartan 6 FPGA. So for that, I think you already know how to write in ISE simulator, then ISE, then how to upload that to the board. I already shown that in the first video. So now just recall all those things. Now we are going to follow the same steps, but now we are going to write the code for the half adder. I think you are now about the half adder. It is okay, just a single bit half adder. That means A, B, two inputs and sum and the carry. Sum will going to be the A XOR B and carry will going to be the AB. That we already know. Now we are just going to do the same thing and implementing that to this board as like the previous. So for that, I just for the simplicity purpose, I already just wrote the code for that half adder. It is just nothing. You need to just declare the module keyword and half adder and the ports. What are the ports we require? Input and output. That is A, B, sum and the carry. Then the next comes a declaration of the output ports and the input ports. So output is the sum and the carry, that is the output from our FPGA or the half adder, then the input and the B. Then we just have to, now I use the data flow modeling, so it is assign sum equals to A XOR B and carry, assign carry equals to A and B. That same thing you can find here. Okay, then before implementing, we just have to write its test bench and we have to check whether it's working properly or not. That's based upon our thinking. That means by comparing this with our truth table that we wrote. That means I think you know how to write the truth table and all. So here you have the two options. One is the implementation and simulation. So before implementing it, we just have to click to the simulation. If you are 100% confident, then you can implement it. There is no any rule that after simulation only you have to implement. There is no any rule like that. But it's better way if we check within simulation than if we upload that. So here, yeah, I already wrote its test bench also. That means it will automatically going to generate the test bench also. I think you know how to add the test bench and how to write the code and the initial setup, all those things. I think you know. This is in XILINX ISE tool. Okay, you just have to go to the start and ISE and this type ISE that I told in the previous video. If you don't know, then just refer that. Okay, then here the main thing. This is the module half adder test bench and AB. Okay, yeah. Half adder this is a little bit changed. Okay, this is similar to what we did in that EDA playground just before the video, EDA playground. So here I just this is for the module name. Module here you can write like this or you can just leave empty also. Then the inputs are all should be the reg for an test bench and the output wire. Then okay, here I'm just going to instantiate my unit under the test. That means this HA, this has to be equals to the name that is our top module have. Here you can see the HA. Okay, that means our design module, design block. Here we have the HA. That same thing we have to write in the test bench, because that is our unit that we are going to take under the test. So that we have to write, and here you can give any name. Then here whatever we are giving the inputs and outputs, that means reg and the wire, that has to be in the same, it has to follow the same order what we have in this implementation ports A, B, sum and carry. These letters may be different. That means different variables I can use in test bench and in here in module. Here it is a capital A, B, S, C, but here I have the small a, B and S, C, but it is like passed by the position. So if we have in the previous video, in the while writing the test bench, or when it generates the test bench automatically, we have something like dot a and in bracket a. That also you can follow, or you can just simply write like this. It is not automatically generated, it's just written by me. So I just write like this, a b s c. Okay, so this a will going to that position, capital A, b and sum and the carry. So here we have that. Then okay, so here uh, a b and c. Okay, these are the some 0 0 0 1 1 0 inputs, the possible inputs. Yeah, I think I missed it. Yeah, 0 0 0 1 1 0 and 1 1, then and module. Only this much is required. But in whereas in EDA playground we need those two extra sentences that I think you remember. That's to dump those waves. So here we don't need that. So if we just go to simulate this, just have to click this and here simulate behavioral model. Do you want to save? Yes, I want to save this. If any error is there, that we're going to display here. Now it is giving the simulation for 10 lakh picoseconds. So instead of that, what we do means we just click here, then okay, now how much second we give the delay here? It is just 10. So here we have to check. I think it's will going to be the 10 picoseconds. Okay, 10 picoseconds. If I tell in a millisecond or microsecond, then that's wrong. It has to be in picosecond. Okay, in previous videos, 10 picoseconds. So we need, how much time you need? 10 picosecond plus 10 plus 10 plus 10. 40 picosecond is enough. That much runtime is enough. So while displaying the wave, we can just here we have it is 1 microsecond. So instead of this, what I write means 40 ps. That means 40 picosecond. Then click enter. Now we can see. Just have to select here the least significant bit. Otherwise, it will just going to change of the position. So just click on your least significant bit and click on next. So this is the first one, 0 0 0 0, all are 0. I think this is the first one. Yeah, 0 0 0 0, all are 0. That's at 0 ps. Okay, then at 10, oh, I think it's 10,000 picoseconds. That's 10,000. So yeah, what I told in the previous is correct. Now what I assumed is wrong. Okay, this is in 10 millisecond. So that's why it's giving here. So here also I think 40. Yeah, I'll just confirm that. Yeah, here the time convention is in nanosecond. It depends upon the time units that consider for the software. For example, here we have in that EDA playground, it is going to be the millisecond. So hash 10 means yeah, here we have the hash 5, that means the 5 millisecond. But here we have the same thing like hash 10, that is going to be the 10 nanoseconds. So why I told means here 30,000 picoseconds is giving, so 30,000 picoseconds is going to be the 30 nanoseconds. That's why it's in nanoseconds. So yeah, now we will check the its output. Now it's 0 0. Yeah, it is 0 0. Then here we can see the 0 1. Then the carry will going to be the 0 and the yeah and the sum. The first one is the sum. Sum is going to be 1. Here we can easily get zeros. A 0, B is 1. So the carry is 0 and the sum is going to be the 1. Value also it will going to show here. Just click on next, 1 0 0 1, that also, and here when we have the AB both 1 1, then we have the carry as 1 and the sum as 0. I think you'll understand that in this test page. Now we will going to implement this. This I'm going to quit. So implementation, and I think you know what we have to do. We just have to generate the yeah, manage configuration project, or I just directly click here. You have to just click on this generate programming file, because we need the bit file. Now it will going to generate that bit file, and it will going to open the window as I click the manage configuration project. So if any error, then we're going to get here. So let's wait for some time, like 30 seconds. Here it is written like 1 tick b 0, like that I wrote. You can even write like a equals to 1 and b equals to 1, because in decimal and as well as in binary, 1 and the 0 remains the same. Now it's implementing, it's generating the bit file. Okay, the name is HA, that we have to remember, hatb.v. the Verilog file, the extension is .v. Okay, now it is successfully configured and it opened this window. Now boundary scan, and here initialize chain. Okay, because we need to add our device, and here it is detected, and we just have to add the configuration file, that is the .bit file. Oh, one thing I forgot. You remembered? I didn't added the pin configuration. So there is no any pin configuration. That means we just defined our input and the output. We not told our FPGA that this is our input and this is our output. That we have to add. So I'm just yeah, this is I'm just cancelling this. Now we have to add that. Okay, no, it is not saved. Now we have to add that file. So implementation, new source, UCF, that's called as the user constant file. So just go to the UCF. Where is that? Oh, where is that file? Yeah, implementation constant file. Here, okay, pinout. I just call it as a pinout and add, click finish. Now it is added. Now here, I as already told, any FPGA you took, there is one manual regarding its pin configuration. Just download that, you're going to get that. So this is XILINX pattern 6 FPGA's configurations. So here I'm going to use my input as okay, first we'll go to output. Here, where is that? Yeah, I'm going to use this one, this LED, and this one for my sum and the carry. That is I think 0, 1, 2, 3, 3 and 4. We are going to use the 3 and 4 now. Okay, because any LED you can use. So 3 and 4, where is that? 0, 1, 2, 3, 3 and 4 is here. I'm just going to copy these two. This is the address of that LED, and yeah, we even need to add our input. So let's copy that. This is our output. So here, what is that? What we have? We have the output as S and C. Okay, so in pinout, this is S and this is C. These two are the outputs, and for the input we have to use those switches. Where is that? Okay, no, I just come to the pin configuration. I think yeah, there's that switch. So DIP switches, I'm going to use the first two switches as my these two. Okay, switch 1 and switch 2 as my input. So I have to paste that, and the name is A and B. Don't give the name that you gave in the test bench. You should have to give the name that you defined in the top model AB. Okay, then save this. Now just go to here again. You have to generate programming file. I think it may take some 30 seconds. Yeah, now it's generating the program file. That's the bit file. I just skip the before step. Yeah, now manage configuration project and boundary scan, initialize chain, and now we have to add where's that, my HA. Okay, so HA dot bit, this we have to add, and this asking for the BPIP room, just click no, that's for the permanent burning of our code. So now click apply and click OK. Okay, now we just keep this one side, and where is that, this one. Okay, this I'm going to just keep that here. Now I just have to program this. Yeah, now it's successfully programmed. Now we will check whether it will going to give the proper output or we need to upload again or not. Now here, I'm keeping this side. So here we have the 1 and 2. I think here we have this 1 and 2, which is at 0 0. So we are getting these to 0, and I think we need to upload this again. Okay, I'm just going to upload that. Okay, now we will check. Sometimes these things happens. We will generate that bit file again. Okay, this I just closed. I think these things are proper, and here in the pinout A, B as F, these things are also proper. Okay, implementation, what is that? I just have to rerun all, just rerun. I just unplug this and plug it again, the boot. Now we will check. And now it's unplugged and replugged. Now we will check. Okay, it is mapping. You can just fast forward these steps. While you are watching this, just fast forward these steps. Nothing's there here. Yeah, it's generating now. Yeah, now I just have to, we'll check now. Yes, and here, where is that bit? HA. I think this is the file. No. Okay, yeah, now we have the board here. Program it. Yeah, now we got the output. That's why I told, if sometimes due to some technical issues it will not give us the output, but we just have to re-upload the code, and the same procedure, there's nothing in that. So now here it is that both are 1 1, that's why it is giving the output carry 1. So now if I make this to both to the 0, I think you can see now both are at 0 0 0, so our output is 0 0. Then if I make 1, I'm going to make this as a, I think it's left. Now it is 1 0. So 1 0 means the carry has to be 0, so the carry is 0, and the sum is going to be the 1. Now if I want to make this above 1, okay, this one 1, then I just make, now I think you observe the change of the light. I think you understood this. Thank you.